Namaskar, I am Anand and you are watching Join for Education. In this class, I am going to solve the questions of exercise 6.3. Name of the topic is Maxima and Minima of functions of one variable. Name of chapter is Application of Derivative, subject Mathematics. Let's see the question number 11. In question number 11, ask us it is given that x equal to 1, the function x to the power 4 minus 62x square plus ax plus 9 attains its maximum value on the interval or closed interval 0 to 2. Find the value of a. In closed interval, x is greater than or equal to 0 but less than or equal to 2. Let's see the solution. So the first derivative of the given function here will be 4 into x to the power 3 minus 124x plus a, and the derivative of 9 will be 0. Hope that there is no problem to understand up to this step. So the first derivative of the function will be 0 when x equal to 0, 1 and 2. So here 4 into x to the power 3 minus 124x plus a equal to 0. Therefore value of the first derivative when x equal to 1 equal to 0 according to the question. So equal to here will be 4 or 1 into x to the 1 into to the power 3 equal to 1 and 124 into 1 equal to 124. So here will be 4 minus 124 plus a. Therefore a will be 120. So this is the answer of this question. Hope that there is no problem to understand the solution of this question. This is the question number 12. In question number 12, ask us find the maximum and minimum value of x plus sin 2x on the closed interval when x is greater than or equal to 0 but less than or equal to 2 pi. Let's see the solution. First derivative of the function here will be derivative of x will be 1 and derivative of sin 2x will be 2 into cos 2x, and here this is the plus because here this is the plus. So the first derivative of the function equal to 0, therefore 1 plus 2 into cos 2x equal to 0. Therefore cos 2x equal to minus 1 by 2. After there is no problem to understand up to this step. This one move in the left hand side, then we get minus 1, and these two move in the right hand side, then we get by 2. Therefore here x equal to 2 pi by 6 or 4 pi by 6. After there is no problem to understand up to this step. Therefore value of the function at x equal to 0 is 0 plus sin 2x equal to 0. So 0 plus 0 equal to 0. And the value of the function when x equal to 2 pi by 6 equal to 2 pi by 6 plus the value of sin 2 into 2 pi by 6 equal to root 3 by 2. And the value of the function when x equal to 4 pi by 6 equal to 4 pi by 6, and value of sin into 2 into 4 pi by 6, it means that 2 pi by 3 equal to minus root 3 by 2. So after there is no problem to understand up to this step, and the value of the function when x equal to 2 pi equal to 2 pi plus 0 equal to 2 pi. So according to this one, it is evident that this is the minimum value and this is the maximum value. So in this question ask us find the maximum and minimum value. So the maximum at x equal to 2 pi is 2 pi and minimum at x equal to 0 is 0. After that there is no problem to understand the solution of question number 12. Let's see the question number 13. In question number 13 ask us find two numbers whose sum is 24 and whose product is as large as possible. Let's see the solution. Let the number be x and y. Therefore x plus y will be 24. Therefore function will be here. Ask us product. Which product? It means that x into y. So the value of y here will be 24 minus x. According to the question here, x plus y equal to 24. Therefore y equal to 24 minus x. So the first derivative of this one will be 24 minus 2x. After there is no problem to understand up to this step. For maximum and minimum, first derivative of this function will be 0 or 24 minus 2x equal to 0. So 24 minus 2x equal to 0, therefore x equal to 12. So the second derivative here will be minus 2, which is less than 0. For all value of x, second derivative be negative. So here x equal to 12 and the y equal to 24 minus x equal to 24 minus 12 equal to 12. So the product will be large as possible as product is as large as possible, then we get x equal to 12 and y equal to 12. So the required numbers are 12 and 12. After there is no problem to understand the solution of question number 13. Let's see the question number 14. Question number 14 asks us find two positive numbers x and y such that x plus y equal to 60 and x into y to the power 3 is maximum. So the function here will be x into y to the power 3 and suppose x plus y equal to 60, therefore y equal to 60 minus x. So instead of y, 60 minus x to the power 3. So the first derivative of this function will be minus 3x into 60 minus x to the power 2 plus 60 minus x to the power 3. For maximum or minimum, first derivative of the function will be 0. Therefore first derivative of the function equal to 0 at x equal to 15 and 60. After there is no problem to understand up to this step. So the second derivative of the function here will be 6x into 60 minus x minus 6 into 60 minus x to the power 2. So the here second derivative of the function equal to 12 minus, here will be 12 into 60 minus x into x minus 30. So the second derivative of the function will be less than 0 or negative at x equal to 15. Therefore, xy is maximum at x equal to 15 and y equal to 45. After there is no problem to understand the solution of question number 14. Let's see the question number 15. Find two positive numbers x and y such that their sum is 35 and the product x square into y to the power 5 is a maximum. Let the number be x and y. Therefore, y equal to 32 minus x. After there is no problem to understand up to this step. So the value of the function equal to x square into y to the power 5. Here y equal to 35 minus x. So 35 minus x to the power 5. So the first derivative of the function equal to minus 5 into x square into 35 minus x to the power 4 plus 2x into 35 minus x to the power 5. First derivative of the function will be 0 at x equal to 0, 10 and 35. After there is no problem to understand up to this step. So the fx here will be x square into 35 minus x to the power 5. So first derivative of the function will be 0 at x equal to 0, 10 and 35. Therefore, x square into y to the power 5 is maximum at x equal to 10 and y equal to 25. So the numbers here will be required positive numbers equal to 10 and 25. So this one will be the answer of question number 15. After there is no problem to understand the solution of question number 15.